Hi students, in this video let's see a famous public cryptography algorithm which is RSA cryptosystem. Let's have an introduction about this algorithm. It was designed by three giant cryptographers, Rivers, Shamir and Adelman. It was one of the public key encryption systems and otherwise known as asymmetric key encryption technique. That means both sender and receiver will use different keys for encryption and decryption process. The different keys are nothing but public key and private key. Public key is known to everyone and private key is only known to the particular sender or receiver. So there are two variations of this one which is depicted in this figure. In the first case, encryption algorithm will be done by the public key of receiver and decryption algorithm will be done by private key of receiver, so that it will provide confidentiality. And in the second variation, encryption process will be done by private key of sender and decryption process will be done by public key of sender. It will be used to provide user authentication. There are three steps involved in RSA algorithm. First one is key generation, next encryption and decryption process. For doing key generation, we need to select two large prime numbers P and Q and we need to calculate the integer value n, which is the multiplication of P and Q. And we have to choose the integer e such that 1 less than e less than pi of 1. Pi of 1 is the Euler-Stasian function of n. Then we have to calculate the value d, which is equal to E inverse mod pi of n, so that we can derive the public key pair as E and n and private key pair as D and n. Public key pair is used for encryption and private key pair is used for doing decryption. So the ciphertext C is equal to m power E mod n. M is the actual message and E is the public key value. And decryption, that is inverse process of encryption, is m is equal to c power d mod n. So we can get the actual message by using this formula. Let's see an example. In an RSA crypto system, a particular user A uses two prime numbers 13 and 17 to generate the public and private keys. If the public key of A is 19 and the message is 8, perform encryption and decryption. From this problem, the given data are P is equal to 13 and Q is equal to 17, two prime numbers, and the public key value E is equal to 19 and the actual message is 8. So the first step is key generation, n equal to P into Q, so we can get the value as 221, and pi of n is equal to pi of P minus 1 into pi of Q minus 1 as per the Euler-Stasian function. So 13 minus 1 into 17 minus 1 is equal to 192. The second step is performing encryption. So C is equal to m power E mod n. Substitute the values here. M is equal to 8, E equal to 19 and N equal to 221, so that we can get the ciphertext as 70. It will be transmitted to the receiver side and receiver will perform decryption by using the private key of its own. So D is equal to E inverse mod pi of n, should be calculated at the receiver side. So 19 inverse mod 192 is equal to 91, and for doing decryption the formula will be applied as C power D mod n. So 70 power 91 mod 221 is equal to 8, which is the actual message. So the advantages of RSA algorithm are it is easy to implement and it is safe and secure for transmitting keys, mostly short-term keys. And the limitation of RSA algorithm is it reduces the data transfer rate because of factorization of prime numbers. Then the real-time applications of RSA algorithm are it will be used in hybrid encryption schemes and digital signatures. So mostly this algorithm will be used in the combination of any other cryptographic algorithms. It is best for short messages transfer like session key transfer. It is used in TLS and VPN. So to make a secure connection, RSA algorithm will be used to transmit the key values. And the best examples of RSA applications are Bluetooth application, MasterCard, Visa, e-banking and e-commerce applications which are used RSA algorithm. Thank you.